So it's great to have you all joining us this afternoon. It was last week that we heard from Lord Knight, who set the context, challenging us as we plan a curriculum that meets the needs of our learners. And this week we are looking to the future. We're considering how we can help our children, how we can prepare them for their future. So we're extremely grateful to have Dale Lane join us. And thank you very much, Dale. There's been quite a few changes and you've accommodated those since you first agreed to speak at our 2020 conference. Dale is a developer for IBM and he holds their IBM Volunteer Excellence Award in recognition of the work that he's done. He's started supporting schools back in 2016 when he began working on a model for machine learning that could be used to provide learning experiences for children and young people. He was part of supporting a lot of schools with STEM experiences. We were introduced to Dale by Lucy Runham at Purple Mash, and we're excited to see the possibilities offered to increase knowledge of how this type of digital system works. One part of helping our learners increase their understanding of their world. So I'm going to hand over to Dale. He'll answer questions at the end of his presentation. So do make use of that chat window. So while he's talking, any thoughts you have, any questions, do add to the chat. So Dale, thank you very much again, and over to you to share your part of the session.
Right, thank you so much for the welcome and for inviting me. Yes, my name is Dale. I'm a developer for IBM, and this afternoon I'm going to be talking about machine learning. My plan for the afternoon is to cover three things. I want to quickly go over a couple of definitions, just so we're all on the same page. Then I'm going to spend like 10-15 minutes showing you some examples of machine learning projects made in the classroom by some of the schools that I've worked with, to give you an idea of the kind of things that are possible. And then finally, I'm going to hopefully get you all to have a go at doing this for yourself. So we'll all finish up by training our own machine learning model. So that's the plan. Like I say, we'll start with a couple of definitions of what we mean when we say AI and machine learning. So AI, artificial intelligence, that is what we call projects where we're getting a computer to do something that's a bit smart. It isn't a description of a technology. It isn't a description of how the thing is being done. It's a description of the objective, of the task, of the goal that of the project. Machine learning is the how. You know, it's not the only way of doing AI, but it's kind of our favorite. It's, you know, it's one of the most powerful ways we know at the moment of doing AI projects. It's one of the ones that we're most excited about. So the distinction I'm trying to make here is between what it is you're trying to get a computer to do, AI, and the way that the computer is going to do it, the technique, the technology, which is ML, machine learning. So what exactly do we mean by machine learning? What is that technique? Traditionally, when you get a computer to do a task, you do it through coding, through programming, by which I mean you tell the computer what you want it to do. You give it the instructions to follow, the steps to follow. You tell it, do this, then do that, and you tell it the order to do those steps in. Machine learning is a bit different. With machine learning, you get a computer to do a task, but instead of telling it how to do it, you show it examples of that task being done. And by showing examples over and over again of that task being done, you are relying on the computer to learn from those examples how to do that task in future by itself, without you necessarily even knowing how the computer is going to go about doing it. So let me give you an example of what I mean by that. Think of the task of being a spam filter. So, you know, a computer is going to see an email and make some prediction about whether or not that is a legitimate email or a spam email. Now, this is absolutely an AI task. It's a complex, subjective thing to make a judgment on whether or not something looks like it is real or legit or not. So there's different ways you could approach this. One way you could do it is find someone who's an expert in spam emails and get them to write a set of instructions. A set of rules for check the headers, and if they mention this, it's probably spam. If the subject mentions this, it's spam. If the body of the email mentions this or includes that, it's spam. And we describe this as a rules-based way of doing an AI project. Now, for some tasks, rules-based ways are fine. For some simple tasks, actually, it's often the simplest and the most straightforward way of doing it. But for a lot of tasks, and for something like a spam filter, it's just, it doesn't scale. The number of rules you would need to write is huge, and the complexity of them is huge. It's probably sort of prohibitively high to try to do an effective spam filter just based on instructions and rules. So instead, what we tend to do nowadays is use machine learning. And by that, I mean, we essentially collect two massive piles of emails, one load of emails that are legitimate and one pile of emails that are spam. And then we use that to train a machine learning system to recognize what spam emails have in common so that it can do the job in future of recognizing what a spam email looks like. That is a machine learning approach to doing an AI task. And like I say, machine learning is the most powerful way we know of doing AI. So that's why you quite often hear these two terms described almost as if they're synonymous, although they're really not, because quite often when we talk about an AI project, we're using ML to do it. So that's all the jargon really that we need to know out of the way. So like I say, because machine learning is the technology that we're most excited about when it comes to AI, and it's the best one that we have, that's what I'm going to be talking about this afternoon. So I want to show you some examples of machine learning projects that I've seen primary school students make in the classroom. So we are talking about collecting examples to train a computer how to do a job. So for this project, the job we wanted the computer to do was to recognize the meaning of a command. We're going to give it a command to either turn on a fan or turn on a lamp. And to get the computer to recognize the command, we needed to collect examples. So in this left bucket here, we're typing in examples of how we would ask someone to turn on a fan. So things like, can you switch on the fan? Please turn on the fan. It's too hot in here. It's boiling. Can we get some air in here? That sort of thing. And in this right bucket, we type in examples of how we would ask someone to, turn on a lamp. And now this isn't meant to be an exhaustive list because we're not trying to do this in a rules-based way. Rather, what we're trying to do is collect enough examples to train a machine learning system to recognize what these have in common so that it can recognize new ways of phrasing this command. So we use these examples to train what we call a machine learning model. That's what we call the output of using this technique to do something. So once we've got this machine learning model, we can make something like this. So that model is represented as this new block here, and we're going to use this to recognize. So we'll get someone to type in a command, and we will recognize the meaning of that command, and then we'll do an animation. We'll take some action in response. So this will be a system that you can ask it to either turn on the fan or turn on the lamp. It will understand what you mean, no matter how you phrase that command, because it's learned to recognize new ways of phrasing it. And then it will take some action. It will do a little animation. So I've now got something that I can come up with a new way of asking and type in there, I think you should turn the fan on, and the fan turns on. This is a really common use of machine learning. Things like Amazon's Alexa or Google's Home device are doing essentially this. They've been trained to recognize the meaning of commands so they can take some action. Now, obviously, they know how to do more than just two commands. They've got, imagine they've got thousands of buckets, and they have been trained really well. So instead of just 10 examples in each bucket, they'll have hundreds in each. But that's just a difference of scale. The fundamental approach and technique and technology is the same as what you've seen here. We can use this not just to recognize commands, but to recognize questions. So in this project, we wanted to train a machine learning system to recognize the meaning of questions that we might want to ask. And the topic for this project was about owls, because that's what we were doing at the time anyway. So we thought of what sorts of questions someone might ask about owls. You know, what do they eat? Whereabouts in the world do they live? How long do they live for? What species of owls are there? And how big do they get? So we created a bucket for each of those kinds of questions that we wanted the system to learn how to recognize. And then we filled them with examples of how we thought people might ask that question. Enough examples so the system could start to learn to recognize new ways of phrasing those questions. Now, once we had that, we trained a machine learning model with it, and then we used it to make this project, which is kind of like a little animated owl character that you can ask it questions about owls, and it's been trained to recognize what your question means so that it can give you its pre-canned answer. This, again, is a really common use of machine learning, increasingly in fields like customer services and retail and financial services. This idea of being able to train an automated system to recognize the meaning of a question and then give the correct answer to them is becoming really, really common. And in a classroom setting, it's actually a really nice project to do because you can tailor this to whatever topic you're currently doing in class at the moment. You know, I've done this with schools where we've made machine learning chatbot Vikings and Romans and Tudors, and we did a William Shakespeare one once. And the same basic idea of, you train it to recognize the sorts of questions someone might ask, prepare the answers, do a little animated character. If you think about it, when you ask your students to research a topic, and there are lots of ways you might ask them to present what they've learned and their research, you might ask them to give a talk or prepare slides or make a poster or write an essay. This is just another way to allow them to use technology to present information. And this way, they're presenting the information in a fun, interactive way. But the same idea of having to research the topic and have an understanding of the topic, identify what the most critical questions are, show an understanding of those questions because they've had to phrase them in several ways, and then prepare the correct responses. So in some ways, almost the machine learning is an incidental part of the broader project. It's not just about recognizing the meaning of text, though. There's loads of other kinds of patterns that computers can learn to recognize from the examples that you give it. So, for example, you can train a system to recognize the emotion, the tone, the sentiment in text. So with this project, we were training a machine learning system to recognize compliments as opposed to insults. So we created this bucket on the left and filled it with the kindest, nicest compliments we could think of. And the bucket on the right, we filled with the cruelest, meanest, nastiest insults we could think of. This project has gone wrong for me before, and I've learned some interesting new words from students by doing this. But assuming you can get through that, it's a really nice, simple example of how computers can learn to recognize patterns in the use of language. Because once you've trained this, you can make character like this, where you can type in a message to it, and it will use what it's been trained. It will use that machine learning model to recognize whether or not you've said something nice to it or something nasty to it. And then we can get the animation, the costume to change accordingly. So you can say something nice, a kind compliment to it, and it will smile. Or you can say something mean to it, which typically is what most of the students enjoy doing, and make it sad and make it cry. Again, this is a really common use of machine learning. The ability to recognize sentiment and tone and emotion in text at scale automatically is really, really useful in fields like HR, in fields like market analysis, in research. The idea to be able to tell at scale with all the text that's being generated on the internet every day, what are the topics that are making people annoyed? What are the topics that people like? It's really, really useful, particularly like internally in large companies like mine, where that ability to look at what are the discussions that we recognize people are very upset about, or people are angry about, or proud about. It's a really useful tool in text analysis. Another way of using it is for recommendations. So what we've got here are buckets representing the sorts of places someone might want to go on holiday. And the examples in the buckets are descriptions that they might give of their hobbies and likes and interests. So what we've got, for example, is, someone who likes to go to a museum might say, I want to do something educational, that sort of thing. And what we're going to use this for is to train a machine learning model so that when it is given a description of someone's likes and interests, it can make a prediction about where they might want to go on holiday. So we can make this kind of like vacation phone app with it. So you tell it what kinds of things you're interested in, and it makes a recommendation of where you might want to go. this idea of using a machine learning system to make recommendations is really common, and we all sort of interact with these kinds of systems every day. If you think of, any time you've had a system that has recommended what video you might want to watch next, or what song you might want to listen to next, or what you might want to buy next, it's all this kind of thing. Imagine for something like YouTube, imagine that they've got two buckets, a bucket of examples of videos that you like, and a bucket of videos, examples that you don't like. And when you click thumbs up, you're putting this video in a bucket of videos that you like, so that you're helping to train their machine learning model so that it can be better at predicting what your likes and use that to recommend what you might want to watch next. It's not just about text, though. So with this project, we were training a machine learning system to recognize handwriting. Anything that you can collect examples of works well. So here we're training it to essentially recognize images. So for this project, we picked a few local cities, and we collected examples of how you would write the postcodes for those cities. Now, actually, you can see that we didn't do the whole postcode. We just did the first couple of letters because this was a year 4 class and we only had an hour. So in the interest of time, we kept it simple. But what we're doing is training a machine learning system to recognize what these postcode shapes, symbols look like. And once we'd collected enough examples, we used this to train a machine learning model, and then we made a postman pat game out of it. So the idea of this is you write a postcode on the envelope, and then when you click on the cat stamp, the machine learning model that you've trained is used to recognize what you've written and then send the envelope to the right place. This is based on how this works in the real world. Large-scale sorting offices automate the sorting of mail and parcels in this kind of way. Obviously, they are recognizing more than just 3 postcodes. They'll be recognizing hundreds, and they'll use more than just a couple of letters to do it. But again, the principle that, that's just the difference of scale. The technique and the technology is very much the same as what the students made for themselves. You don't have to get the students to type all their training examples in or draw all their training examples in themselves. So with this one, we made a Pac-Man game. And what you can see here is the student is using the arrow keys up, down, left, and right to control Pac-Man, to move the character around to avoid the ghost. But at the same time, every time they make a move, the coordinates of the Pac-Man character and the ghost character, those 4 numbers, are added to the training bucket for the direction that they went in. So what they did, just as a result of playing the game, was fill up the training buckets like this. So, for example, you can see, when Pac-Man was at XY44 and the Ghost was at XY53, they went left. So what they're doing, by playing the game, they're training a machine learning system to learn how to play the game for itself. And then they could see that running by removing the arrow keys from the control and putting their machine learning system in charge of the character, and then watching it play itself based on how they've trained it to play. Similarly, they don't have to draw their own training examples. So in this project, what we were doing was training a machine learning system to recognize, to predict what type of book a book is based on a picture of its cover. And the way we did it was we opened a second window up on the side, and then I think it was like a library website or a bookshop website, something like that. And then they found book covers they liked the look of, and then clicked and dragged it over and dropped it in the training buckets. So by doing that, it's really quick and easy to come up with a set of training images like this to train the computer from. And what we were doing is training it to recognize when you show it a new book, to get it to make a prediction of whether or not that book is probably a romance book or a sci-fi book and so on. And the computer would be learning from the examples it was given to recognize patterns like the use of colors or the use of fonts or that sort of thing. And then we used that to make a project where we could show it a new book that the system hadn't seen before, and then it would predict what type of book that was just from the image of the cover. And I've done this project a few times. You can do it with movie posters or album covers or game box art, anything that you've got that sort of genre consistent idea to. It tends to work really well. If you've got microphones on your computers, you can use them to capture sound recordings and then train a machine learning system to recognize sounds. Now that can be speech, it can be spoken words, or it can be any sort of sounds, different musical instruments or finger clicks or claps or whatever it is that you want to build your project around. With this one, we trained it to recognize what we were saying to represent a few different places. And then we used that to make a project where it was listening out for what we were saying. And then when we said the word, the little character would go to the place where it heard us say. And again, this is a really common use of machine learning. You know, that's how devices like Alexa are listening out to hear the word Alexa and then respond when they've heard you say it. So that's enough examples for now. Hopefully that's given you a flavor of the kind of things that are doable. So like I said, what I'm going to do now is I'll walk through from scratch creating a project, and hopefully I'll go slow enough that you can all follow along and try it for yourself. And then once we've done that, I'll finish up with some questions. So hopefully you can get to this site, machinelearning4kids.co.uk. In fact, I will put the URL in the chat to make it a bit easier. So the first thing to do is to click on this blue button down here, Get Started. So if you can do on that, you'll get to this screen. Now, what this is showing you is you can create an account if you want. There are some benefits to doing that. It means that you can save your work and come back to it later. It means you can get your whole class to work collaboratively on the same project, so they can all contribute training examples to the same project, which can be a nice way of collecting loads of examples really quickly. But you don't have to create an account. The site is totally usable without any registration or usernames or passwords or anything like that. And that's what we're going to do today by clicking on the button down the bottom, Try It Now. So if you can click on that. So the site is project-based, so you can create multiple projects. So the first thing to do is to create a new project, which you do with this plus button up on the top right. So there are different types of projects, and hopefully I've given you a feel for that with some of the examples I've shown you. You can train it to recognize based on examples of text, pictures, numbers, or sounds. For now, I'm going to go with images because it makes it nice and easy. So please choose images, and we'll need to give it a name. I'm going to go with shapes because what we're going to do is train a computer to recognize a couple of types of shapes that we're going to draw. So yeah, give the name shapes, pick images, and then click the create button down in the corner. So this is your list of projects. So, you know, at the moment, we've only got one because we've just created one. So we'll just click on that. So this screen, what it's doing is it's showing the 3 phases of a machine learning project. On the left, we've got here collecting those training examples, creating the buckets and filling them with the examples. In the middle, the second phase is using those examples to train a machine learning model. And then once you've got that model, the final phase is to make something with it in Scratch. So we'll start at the beginning on this left button, Train. So to create a bucket, we're going to use the button in the top right, Add New Label. So create a couple of buckets representing different shapes that you're happy drawing. So I'm going to go with triangle, and then I'll click that button again, and I'll do circle for my second one. So you can do anything that you're happy sort of drawing. And then once you've got your 2 buckets, each bucket at the bottom has got buttons for how you can add examples. We're going to use the draw one, which brings up this canvas, and then just kind of draw an example of what that shape looks like. Doesn't need to be neat. It doesn't need to be perfect artwork. You know, rough, quick scribble is plenty good enough. We need 10 examples in each bucket. So I will leave people for a few minutes to do that while I also do it myself. Oops, that one. Like I say, it really doesn't need to be perfect. In fact, in some ways, it's better if it's not perfect because then it will learn to recognize rough and scrappy drawings. If you only show it perfect examples, then it will only know how to recognize a perfect example. Oops. You can see the count of how many examples you've done in the bottom corner. And so you want to get to 10, ideally. Oops, no, that's not the right one. I was going to do circle. Oh, circle's even harder. Right, so when you've finished, it will look like this. But like I say, I'll give people a couple of minutes just to catch up.
I'm wondering whether with this example, Dale, I shouldn't say I'll change my wording. The youngest children, this could be a great way when they're first exploring shapes to build up, can I get ways so the machine would recognise my shape? I don't know what age is the youngest that you've worked with?
I think year 3 is probably the youngest I've worked with. I mean, definitely this project, I haven't done exactly this with a class before, mainly because it's quite a boring thing to do. But it's nice. I thought it'd be quick and easy. I think it requires a bit too much mouse coordination. I think for schools where you've got touch screens, I think it would work well. But I think with a mouse, it might be a bit of an ask for the mouse coordination needed to draw a shape. But I don't know. I haven't tried it, so it'd be interesting to see whether or not it worked. I'm going to assume that people are okay for me to carry on. I hope that's okay. So now I've got my training examples. In the top left, there's a link labeled back to project. So that gets me back to these 3 phases. So now I've done phase 1, I'm going to do phase 2, which is training the model. So now I'm on this page. There is only one button to click, which is this blue train model button. Now, if you don't have that button, it is almost certainly because you haven't got enough training examples yet, and the text at the top of the page will explain that to you. But assuming you've got enough examples, you should have a button here to click. Now, how long this takes kind of depends on how fast your computer is. It can be anything from a couple of seconds. Oh, mine's already finished. But if you're running this on something like a Raspberry Pi or PiTop or something like that, it might take 30 seconds, it might take a minute. So just be a bit patient with it, I guess is all I'd say. So now you've got a machine learning system. The next thing we do is we test it. We make sure that it's working. In the same way, I guess, to use an analogy, when you teach something to your students, to see whether or not they've correctly understood what you've taught them, you give them a test. And we do the same with machine learning systems. So you can do that with this test by drawing button. So if I draw a shape here, whoa, that went all over the place, and then click on test, it tells you what it thinks it's recognized. And you can see that it's got it right. So if I test it with a circle, oops, yes, that works. And you don't have to test it with drawing. So if I try with the webcam and I will draw a circle, where's my webcam? There it is. Let's see if I click on test. There you go, circle, 98% confidence. And you can test it with pictures on the web and so on. So I'm happy with that. It looks like my machine learning system is working. It's correctly learnt to recognize the shapes I wanted it to. So, back to the project. The next step is to make something with it. So we'll go into Scratch. So if you just follow the blue buttons, click on to make, click on to Scratch 3, and then click on Open in Scratch. And once you get to the end of following those blue buttons, it'll open up a new window with the Scratch site in. Now, hopefully Scratch is familiar to you. I'm sure that you've used it before, so I won't sort of explain any of that. What we're going to do is just show you how you can test your machine learning or use your machine learning system in Scratch. So what we'll do is if you create a new sprite using the paint tool, and we just want to draw a shape. So I'm going to use the paint tool to draw a sprite that, whoa, that was pretty poor. And do a couple. If you know how to add the costumes, use the paint tool in the bottom left corner where it's there, and you can go to the paint option and you can add a few examples that we're going to use to train it. Actually, I'm going to get rid of that cat sprite because I don't need it. So what we're going to do is we're drawing costumes on our test sprite that we can use to test the model with. So once you've got your sprite ready, you've got your costumes, in the code, we'll just do something really quick and simple. Let me make this bigger so you can see. When I click the flag, I want it to go to the next costume, and then what shall we do? We'll just get it to say what it thinks it recognizes. I'll finish the code and then I'll explain what it's doing. There we go. So yes, when you click on the green flag, it's going to switch to the next costume in the set. It will use the machine learning model that you've trained to recognize the image for the costume. And it will do a little speech bubble to say what it's recognized. So most of these blocks I'm using, the green one is down the bottom of the list in images, and all the machine learning ones are right down the bottom of the list. And it will be called whatever you called your project. So for me, it's called shapes. And then once you've got that, you just click on the green flag and see if it works. The first time you use it, it will be slightly slower as it loads the machine learning model into memory, but after that, it should be pretty much instant. So it's recognized that as circle. If I click again, it's recognized that as triangle. There we go. Now, this is absolutely not an inspiring project. And like I say, not one that I've done with a class. The reason I showed you the demos first was to hopefully inspire you in the kinds of things that are possible. But I wanted, for this, I thought we'd just do something really quick, just so you've gone through the process and seen how to do it for yourself. So I'll just give people a chance to finish up whatever, sorting out the code for their projects. Hope people have been able to follow along and get this working for themselves, but I guess I'll find out in a minute when we go for questions. Now, if we want to be awkward, we can try and confuse it. So let me try and, this is going to tax my art skills. No, what I'm trying to do is to draw an ambiguous shape, something that looks a bit like a triangle, but has curved sides like a circle. See, that doesn't look enough like a triangle. Let's see what it does with that. It thinks that is a circle. Yeah, let's try that one again. Circle again. So the interesting thing is to try, and actually it's easier to see from this learning test screen when you're testing it of, so for example, I didn't show it any examples of a triangle looking upside down. So it'd be interesting to see what it does with that. Oh, so it's slightly less confident of that. Actually, that's pretty good. If I try and draw one that's at an angle like this, 98%, whereas if I draw one like all the examples I taught it with, it should, yeah, 100%. So, I mean, what this task of getting a computer to recognize two shapes, and I picked two very distinct shapes between a circle and a triangle. This is a really easy thing for a computer to learn to do. I mean, you saw it from the fact that it trained in a second or two, and it's getting pretty much everything right with 100% confidence. So it's really easy for students to come up with an idea of what they want to make and to do it for themselves and to see it working. Just quickly before I finish up and let's go to questions, I just want to show you a couple of other bits. Worksheets tab along the top. So this is where there are instructions for how to make a variety of projects in there. So if you pick one of these, so I showed you this one when I went through the demos. This one is the Alexa one where you train it to recognize commands like turn on a lamp or turn on a fan. So each one has got a sheet for you as the teacher, basically some gotchas to watch out for, common mistakes students tend to make, things you might want to point out, and then a sheet that you can print out and give to your students. They're all available as PDFs or as Word documents. They're available as Word documents, so if you want to customize them, tweak them, change them, you can tailor them to fit. But what you get if you just stick with what's there is step-by-step instructions that tell you, where to click, what to do, now click on that, now click on this button. So if you just want to use it as like a recipe and follow along exactly, you'll end up with a working machine learning project at the end of it. And each sheet sort of calls out what are the real world uses of machine learning and AI that project is based on. And it suggests some extensions that you might want to do as well. So I mentioned sort of some of these as I was going through the demos, but there are loads more in here. So hopefully there's enough ideas in there to get you started, either to help you think of things that you might want to do, or just you can sort of take one of these as is and use it as in the sheet. The other thing that's available here is pre-trained models. So there are some machine learning tasks that are so complex that it's probably not realistic for students to train it themselves in a single lesson, just because the number of examples they would need to do is prohibitively high. So, I mentioned that, yes, you can train a sound recognition, and you can train it to recognize, the example I showed you, we trained it to recognize 4 words. But if you want to do something a bit more than that, to recognize whole speech, that it would be very difficult to do that in a lesson. So what I've got here is I give you a few pre-trained models that have been trained with massive numbers of examples, so that you can just allow your students to make things with them and to see what machine learning is capable of. So, for example, if I go with this, so all of these ones you can see in this graphic here, they're all added to Scratch down in the bottom corner. So if I, actually what I do is I'll open a new window, close these. Yep, don't need that anymore. So if I go here, you can see the ones that are available. So if I show you the speech to text one, what that does is recognize more than just individual words, but it can recognize whole sentences. So what I'll get to show you what I mean, I'll just quickly do. So what this is doing is when I click on the green flag, it's going to start listening, and then it's going to say what it's heard. So if I try that now, hello, thanks for listening to this talk. And there you go, you can see it's captured what I've said. So they haven't, the downside with pre-trained models is there's a bit of a loss there, that the students haven't trained it for themselves and they haven't seen what's gone into training it. But the benefit is it's going to be a really well-trained model that is really very powerful, and more powerful than what they're going to be able to train for themselves in a single lesson. And it does mean you can do some fun kind of things. So if I just do one more example, I'm going to use the webcam for this one, and I'm going to use the face tracking. So what this is going to do is find the location of, oops, I didn't want to do that. See, now I've got 3 of them. Let me turn off that transparency effect because it's not very helpful. What I'm going to do is choose a ball costume. I'm going to try and get the sprite to follow my face. So the script for this is pretty simple. When I click the green flag, I want this sprite to go to, let's start with following my nose. Oh, I've done X and X, that's not helpful. Let me pick the Y one, that's that one. There we go. Actually, I don't want it to do it once, do I? Let's do it forever. So now that should start, and it's really hard to do. Well, I can't. So hopefully, if I move around, you'll see this follow. And you can do the same for, if I stop that, you can do the same for eyes and mouth. So you can do like animated cartoony things with cartoon effects following your face around. So those are the kinds of projects that you can do that are maybe a bit hard to train for yourself, but it extends the range of things that you can get your students to try out. So that is everything I wanted to show you. I started with some definitions. I talked about what do we mean when we say AI? What do we mean when we say machine learning? I showed you a few examples, and those were all examples of projects that I've done with primary schools, so that I've seen students make. And I've hopefully tried to point out as I went along how they're all based on real world uses of AI and machine learning, and that's very much intentional. The idea isn't just to teach kids new type of technology for the sake of technology, but to help open their eyes to how AI projects are all around us, how these technologies impact us all every day, and to get them to be a bit more aware of how the world around them works through these examples. And finally, I hope that at least some of you were able to train your own model to recognize your scribbled shapes and see how you can use that machine learning model from scratch to start making your own projects. And with that, thank you very much for listening, and let's do some questions.
So Dale, are you able to see the question that's in there. What would happen if you showed it a shape that is neither a triangle or circle?
Oh, that's a good idea. Yeah, let's let me share my screen again. So the important point here is machine learning systems are not all-knowing, all-seeing, all-powerful things. They only know what you've taught them, and they only know what you've shown them from the examples that you've shown them. So it's a really good point of, what we've built here, or what I've trained, is something that knows how to recognize triangles and circles, and it doesn't know how to do anything else. So if I give it, a wavy line, it's got it wrong. So actually, that is surprisingly high confidence. I was not expecting that. Oh, that's a bit more like it. So it recognized some of the peaks of my waves as being maybe similar to triangles, but the confidence is lower because it's not exactly like the examples it's shown before. If I do, what can I do that is very different? Let's go completely bonkers and fill that. So I'm really surprised at how high that is. In principle, the idea is it still has to pick one of the two things because it only knows those two buckets. So it's going to give you an answer that is circle or triangle. That's all it knows how to do. But it should have a much lower confidence that that is the correct answer if it has correctly learned that what you're now showing it is something different. So what we would do in the real world is either leave it like that and just rely on that confidence score to tell us when what we've been given isn't something like we are looking out for. And you see that in, if you've ever asked Siri a question or Alexa a question and its answer was, I'm sorry, I don't know what you mean. It's relying on that confidence score to tell it, oh, hang on, this doesn't look like any of the examples I've got. I'm not sure what that means. Alternatively, what you can do and what is useful for some projects, particularly here where this has got much too high confidence in the incorrect answers, what I would do next is go back to the train one. I would add a new bucket for unknown or don't know or ignore, and I would add lots of things that I don't want it to recognize. And when we do this in the real world, what we tend to do is collect these examples from things that people have given to the real system. It's really useful to not just try and do these as abstract, but to get real world examples of what people have tried to do with it, and then use them to train the system of how it should correctly behave in future. So I'm trying to be imaginative now, come up with all the things that someone might do that isn't a triangle or a circle. That would do. I'm going to go back and train a new model. And this idea of actually doing it iteratively, train it a bit, test it a bit. Oh, it's getting that wrong. Train it a bit more, give it some more examples. Okay, here we go. So now, hopefully, if I do wavy lines, it will say unknown. Brilliant. So yeah, you start off with the confidence score. If that confidence score isn't really cutting it, you try giving it more examples, because generally the more examples you give a machine learning system, the better they behave. And if that still doesn't cut it, then you just need to show it. Here are examples of things that you should ignore, or here are examples of things I don't want you to do something with, by giving it a mistake, or I'm sorry, or I don't know, whatever you call that bucket. And you just fill that bucket with examples of, these are things I don't want you to respond to. So yeah, that's a really good question, and it's a really common part of real world projects of trying to come up with what is the best way to get the system to handle unexpected questions. And you see this in the real world. I've done loads of machine learning, like chatbots, where I showed you questions that have been trained to recognize the meaning of questions, so it can give you an answer. And I've done those for retailers and for banks and for the company HR systems. And you always get people asking it, what's the capital of France, or who's the president of Germany, or whatever. They come up with completely random questions. Or people will ask it things like, please make me a sandwich. So you need to make a system that's trained to be robust enough to handle those kinds of out of band, off scope questions. Any other questions?
There's a question here, is this best for year 3 upwards? So you referred to it being year 3, the youngest that you'd worked with. I don't know whether I have immediately started thinking of ways it could be used with younger children. I was thinking about my granddaughter, who was just learning recognising shapes in Kandinsky Kandinsky paintings, and was trying to recreate them. So as a reception child, I don't know, I could imagine a class queuing up to have their go at training it. But for what you've done, you'd say year 3 upwards from your experience?
I wouldn't necessarily say that. I think, the schools I get to work with is more a product of schools who find out that I exist and ask me, and schools that have time in their calendar to make room for a machine learning lesson and things like that. So I imagine you could get it to work with younger. Now, in terms of where I think some of the differences are, like for something like this, you want to train it to recognize the meaning of commands. I would say this is probably too much typing for a year 3 student to do in a single lesson. I mean, I don't know, maybe you've got some students who are really fast at typing, but if the ask is type 20 sentences and then still make a Scratch project at the end, my guess is that's a bit hard. Now, that's where I mentioned that there is support in the site for creating an account. And what you can do if you do create an account, and it is free to do that, at the risk of this sounding a little bit promotion-y, if you get them to create an account, you can get all of them to work on the same project. So then what you could do is maybe in a class of 30, you ask every student to type in 1 sentence or 2 sentences. And if you do that, then you really quickly get 50 or 60 sentences. So even with younger students where there are challenges like the amount of typing, I would say there are ways around it to make it work. So that's just in terms of mechanically, like what age do I think would be able to go through the steps of doing a project. In terms of the understanding, I've definitely seen that even young children can intuitively get the idea of, I give it examples, it learns from those examples how to do the thing. If I show it something new that isn't like an example I've shown it before, it's not really sure what to do with that. It's reasonably easy to anthropomorphize it, and even with young students, I haven't experienced that being a major challenge. There definitely are nuances that I think students might need some nudging to pick up on. So, for example, I did a project using the webcam. We did a rock, paper, scissors. So what we did is we held our hand up to the webcam, 3 buckets, 1 bucket of rock, hand shapes, 1 bucket of scissors, hand shapes, 1 bucket of paper, hand shapes. And that nice thing of that is there's virtually no typing. It's all just holding your hand in front of the camera and clicking the button a few times. So that's nice and easy. But I remember one of the first times I did that project, I had a class where a student had really good examples for, actually, first what I'll say is, you always get some students who are really super keen. So if I go rock, paper, scissors, I'll do images. So what you do is you create a few buckets and you hold your hand up to the webcam to take a picture. Yes, allow the webcam. So you do, sort of that. And then you do the same for scissors and paper. And there are always some students who just hold their hand roughly still, hammer the picture button and take 10 almost identical pictures. And their machine learning model tends to be pretty poor, gets a lot wrong. And there are some that will do some really close and some far away, and some at different orientations and angle, and some with their right hand and some with their left hand. And that variation in the training data is really, really useful. And you end up with a machine learning model that's really good at handling no matter what hand it gets and what orientation it gets. So that sort of subtlety, in some ways, it's good for the students to stumble on that themselves. I try not to point it out to them up front, and it's much more effective when you've got a bunch of students in the class. Some of them are working well and some aren't, and you get them to look at each other's training data and sort of say, well, why do you think theirs is better at handling pictures of right hands, whereas yours is only working if you show it a left hand? And with a little bit of nudging, sometimes the younger ones will still get it right, but they need maybe a little more guidance and nudging towards the right answer. Whereas with the older kids, they pick it up really much quicker. So yeah, this is a very long-winded answer to your question. Sorry. I think there's 2 aspects. There's the mechanics. If you're going for something like a typing in or something that requires coordination of drawing with a mouse, maybe that's easier with the older kids, but there are ways around that, either by just sticking to a project that needs a webcam or sticking to a project where you get them to collaborate and contribute training data together. And then the other aspect is around understanding of the technology and the behavior of the technology. And I find that actually hasn't been a challenge. You maybe need to give them a little more nudging, but generally I found that even very young children can intuit the basic ideas.
Thank you. There's a question from Janine, that you've probably answered somewhat in what you said already. I don't know whether you'd like to add anything further.
Yeah.
She's asking about how much previous knowledge children would need before starting a project.
So as you've sort of seen, all of the examples I'm showing you are Scratch based. So I do sort of assume that students are familiar with Scratch before they start. And, I don't do a lot to explain what a sprite is, what a costume is. The idea that Scratch scripts are color coded. So if you want to find, a green block, you go to the green section, all of that kind of stuff. And then generally that hasn't been a challenge. I found that most classes I've gone into, there is enough of that knowledge there, but certainly that is the biggest prereq, I would say.
Thank you. Thank you, Veronica, for your comment about you've had a go at the Harry Potter sorting hat example.
Yes, actually, let me give a description of that for people who maybe aren't familiar. So with that one, what we do is we train the computer to recognize the use of language. So it's this one here. And what it is you type in quotes from different characters. So you have 4 buckets, a bucket for Hufflepuff, a bucket, I wish I hadn't started saying the house names now, a bucket for Ravenclaw, and a bucket for the other 2. And you type in quotes from characters. And what you're looking to see is, can the computer recognize that, Slytherin characters tend to say aggressive, harsh, mean things, and Hufflepuff characters tend to say fluffy, bouncy things, and whatever the Harry Potter house is, say heroic, brave, bold things. And actually, you tend to find that because the character personalities are so represented so clearly by the houses, that you end up with a machine learning model that tends to do a reasonably good job. But to get that to work, you kind of need like 10 to 15 quotes for each house. So again, it comes back to you're looking for 40 to 60 sentences. And not only is there a lot of typing involved, but they have to go and find those quotes in the first place. So there are 2 ways around that. Firstly, like Veronica said, you basically split it up. So you have one lesson where you're just collecting the examples and then you do the coding the other one. The other way is, like I was saying, you don't try and ask one student to type in to find 40 sentences. You get them to do it collaboratively. You get them all to log into a shared project. And then, you maybe say that this table, you lot are finding Hufflepuff quotes. This table, you lot are finding Slytherin quotes. So that's what I've done when I've done it with like year 4, year 5 classes. And that helps. And in fact, what they tend to do is they tend to get competitive. So like the table that's doing the Slytherin quotes are going to try and find more quotes than any of the other tables. And that sort of fires them up and gets them going. But absolutely, the projects, collecting training data is absolutely the most time-consuming bit of a machine learning project. And that is not a student statement. That's the problem with machine learning. That's, when we do a real-world business corporate machine learning project, the biggest thing when we're doing project planning is figuring out where we're going to get the training examples from and how, have we got enough time and hands and people to help us do that? And actually, in a way, getting students to recognize that by doing that, seeing that for themselves, it's a really useful lesson for them to learn. That actually the challenge of machine learning projects is not only the grind of getting the training examples, but that it is quite an effort. So I think that's a useful insight that it gives them.
Thank you. Just one more, and I wonder whether you could answer this in about less than a minute. A bit more technical question. From Edmund, the question around using that type of technology.
Okay,
How you prevent it from going rogue.
So it comes back to what I was just saying, that our biggest challenge we face when we build these systems is how are we going to get enough training examples? So what we quite often do is we try and cheat and get the public to train it for us. So for example, if you've ever seen one of those systems where you're shown a photo and it's asking you to quote unquote prove you're a human by clicking on where the traffic light is or where the lamppost is, what you're doing is training a machine learning model. Google wants to build a self-driving car. They need a machine learning system that knows how to recognize stuff on the road. It's too time consuming for them to come up with all those training examples themselves. So if they ask 1 billion people around the world to give them a training example each, awesome, they've got loads of training data. So it's this idea of crowdsourcing, training a machine learning system, really, really common, really, really useful. But as Edmund points out, there's risks because you're trusting the public to not give you, basically you're allowing the public to train your system and they might train it badly. The main way we do this in the real world is we try to give the same example to multiple people and then compare the answers they give. So, thinking of that clicking to find a traffic light thing, we might show that example to 10 different people or 20, 50 different people and hope that we can look for the majority, and anywhere where you can see outliers, those are the training examples we probably don't trust and we probably don't want to use. So we use consensus-based approaches to try and give us that safety net, but it's not foolproof. And you show an example to 50 people, you might have 48 people who are taking the mick and trying to mess up your system. So you do get systems like the one he's pointed out, or a Microsoft one, who got trained to say some really horrid things, some really horrible things, because there weren't safeguards in place to check it.
Thank you, Dale. I'm a bit mind blown. What a clever, simple, complicated idea to help build that understanding of something that's part of our world and children will be experiencing. What a concrete way for them to gain understanding of machine learning. And thank you for your bravery in trying to provide a hands-on experience as part of the session. I've learnt an amazing amount in a short time and really excited about developing that understanding of how something like Alexa works and how that can be combined with questioning around a current topic. The potential cross-curricular links are really exciting, and that development of children's vocabulary. I can see I've got thoughts about using it within online safety learning experiences to get children to understand filters and maybe their need to filter themselves as well. And mathematical links where children are learning properties of shapes, but perhaps recognising 2-digit, 3-digit numbers. I certainly want to have a go at showing how Christmas cards will be delivered this year. So, Dale, thank you for sharing this wonderful resource and explaining the concept of machine learning within that and that differentiation with understanding AI. That's been great.